Arithmetic and geometric sequences, identifying and writing an explicit rule. The sequences below are either arithmetic or geometric. For each sequence, determine whether it is arithmetic or geometric and write the formula for the nth term, a sub n, of that sequence. So all that means, writing the formula for the nth term, a sub n, of that sequence, means writing the explicit formula. Okay? Because we want to be able to just jump to the nth term, a sub n. We want to be able to find the value of any term number in the sequence without having to find all the previous term values. Alright, so first I need to find the pattern in each of my sequences. So here we see 17, 20, 23. I see a pattern here of adding 3 every time, which makes this arithmetic because we're adding every time. And arithmetic means a common difference, which I'll put as 3. So to find the explicit formula, a sub n, I need to start with my starting value, which is 17, and I'm going to add my common difference, 3, multiply that by n minus 1. Now, if you look at your notes, that's the basic formula. You do your starting value plus your common difference, so this is your starting value, plus your common difference times n minus 1. That's always how you do it. Now, if you want to understand where that comes from, let's think about our sequence here. We have 17, 20, 23, 26, and so on. To get from 17 to 20, we already discovered we add 3. But the point of an explicit formula is to start with the first term and be able to jump to any term in the sequence. So let's watch the patterns of jumping to a different term. So to get from the first to the third, we add 3 twice. To get from the first to the fourth, we're going to end up adding 3 times. So here, this repeated addition we see in this multiplication here. So to get from the first term, a sub 1, to the fourth term, a sub 4, we add 3 times. So if we thought about the formula here, 17 plus 3 times 3, which would be adding 9. And that's how we can see it. Now to do the next one, I again need to find a pattern. So I go from 7 to 28 to 112. Now I see multiplying by 4 here, because 7 times 4 is 28, and 4 times 28 is also 112. So I see that this is geometric because we're multiplying, and that means my common ratio is going to be 4 because I'm multiplying by 4. So again, an explicit formula tells me that I'm going to start with the starting term here, which is 7, and I'm going to multiply, because we're multiplying our ratio, by my ratio to the n minus 1, where n minus 1 is an exponent there. So again, if you just want to memorize the formula, the starting value times the ratio to the n minus 1, you're welcome to do that. But to see the pattern, let's put our sequence over here. We have 7, 28, 112, and let's see, 448. So to get from 7 to 28, I multiply by 4. But to jump to the third term, I multiply by 4 twice. To jump from the first to the fourth term, I would multiply by 4 3 times. So to get from a sub 1 to a sub 4, my fourth term, I see that I'm doing 4 times 4 times 4, or 4 to the third, which is what we would end up plugging in here to find the fourth term. So the repeated multiplication ends up looking like an exponent, whereas the repeated addition looks like multiplication here. And that's all you have to do.